Hello guys, so in this video I will just explain the question because the question itself is hard to understand, so I don't know if I will solve it, but I will explain the question and hopefully it will help you understand and maybe resolve it. So this is the question of the contest 207, is the question 4, so it is a hard question, and the question that what is the description is given two groups of points of size S1, which is the rows, and size S2, which is the columns, and the rows are bigger or equal to the column size. Okay, and the cost of the size 1 is one group and the size 2 is another group, and both have points. Okay, both groups have points, and the cost of connection between 2 points is represented in a matrix cost. Okay, and to understand and the row index indicates the points in the group 1, size 1, and the index of columns indicates the points. Okay, the position of the points in the group 2. So to connect two points of 2 groups, what do you have? To find the cost of the connection of 2 groups, you have to use the index of both and find the cost in the matrix. So the index of the first group and the index of the second group will tell you the cost of connecting the 2 groups. So this E will be a point you see in here, point E. Okay, the indexes are the points, and J is the second group point. Okay, so the groups are connected. Okay, the groups as a whole are connected if each point in each group is connected to 1 or more points in the opposite group. Okay, in other words, each point in the first group must be connected to at least 1 point in the second group. So what do we have in here? That's exactly what we have here. Okay, but a few observations can be done. So how many groups, how many points we have in the first group? How many points we have in the first group? We have as many groups as rows. Okay, the number of rows will determine how many groups we have in the first group. How many points we will have in the second group? The number of columns that we have. And remember, the number of rows is bigger or equal than the number of the number of points. The number of rows in this matrix, or the number I'm sorry for the confusion, but the number of rows in this matrix is bigger or equals to size 1. So this looks like a square matrix. Okay, but it could be like rectangular with more with a greater row size. Okay, like something like this. So we have that situation here. Okay, all the points are connected, and here again all the points are connected. But if you are still not understanding what's going on, it's not your fault, okay? Because this exercise could be more better, okay? It could be better written and have more data, okay? Some data is, on my understanding, omitted in here and in here. So this is just a solution. This is not the representation of all this data. Neither this one, neither this one are fully represented. This is only the solution on my given my understanding. So I will try to explain what is in here. So this is the same information that we have in the in the question description. So let's start looking at this. This is the representation of the first case. So as I told you, the size 1, let's start here. So size 1 is bigger than size 2, and E is size 1 and J is size 2. So you can see here by the colors the members of the groups, okay? Pink, size 1, 2, blue is the group 2. So they are represented in here, okay? LeetCode this time they didn't help, and they represented as 1 what is the index 0, and they represented as 2 as the index 1, okay? And A and B represents the 0 from the blue group and 1 from the blue group, okay? So what we have here, 0 0, it means that the connection between the point 0 and of one group and the point 0 of the other group it costs 15. So 0 1, we connect the 0 point of the first group to the 1 point of the second group, okay? And the value and the cost is 96. And then 0 to 1 to 0, 36, and 1 to 1 is 1, is 2, sorry, okay? So what does it take to have all, what is the minimum to have all the points connected? So is this one, okay? These two are connected with 15, and these two are connected with a cost of 2. This is the minimum, this is the solution, and this is what appears in LeetCode. Now the second case is a little bit more complex, but the logic still applies. So let's see how we come to this solution. So the same logic applies, only 2 groups, and as of now you might already understood that we are dealing with a graph, and it's not only a graph, but it is a bipartite graph. I don't know if this will help or not in the construction of the solution, but I want you to know this. We are dealing with a graph, and it is a bipartite graph. So we still have 2 groups, the pink group and the blue group, and what we have here is a connection between all the groups, okay? 0 0 cost 1, it is here. 0 1 cost 3, it is here. 0 2 cost 5, here. 1 0 1 and 0. 1 1 1 and 1, it is worth 1. 1 2 1 and 2 was 1 and 2 0. Okay, you get the picture. This is the representation, the complete representation of this matrix given the problem description. Now, with a little bit of analysis, we check whether or not all these points are connected, and they are. Okay, they undoubtedly are connected. But the thing is that we have to find out what is the minimum connection. Okay, so and by that I mean the minimum connection cost to all nodes to be connected. And if you do this analysis and look through this, you will find that for instance, it couldn't be 0 0 1 1 2 2 because 2 2 is worth 3, 1 1 worth 1, costs 1, 0 0 costs 1. So 1 plus 1 plus 3, it's 5. So is there a better route that will a better way of connecting these points that will give us a lower result? And the answer is yes, it is. So we can still connect 0 0, which is 1 and is the minimum, and we connect already 2 nodes. Then we can connect 1, and we will connect 1 with 1, it is the minimum also, and we have connected 2 nodes. And the minimum connection for this one is 2. Okay, I'm sorry, 2 0. The minimum connection for this node is 0. So we have this connection here. So we have already this node connected, we have this node connected, we have this node connected. But look, there is one node that is not connected, and is this one. So as we are at the moment, the solution is not valid, and the minimum connection to this point is this one. And if we see how much each of these connections worth, we will see that this one is 1, this one is 1, so the sum is 2, and plus 1 and plus 1. So this is 4, okay? And this is the actual solution of this problem. I don't know if I will be able to solve it, but this is the explanation of what LeetCode has unfortunately written very badly and didn't help out putting these values here, 1 2 3 A B C. It looks like even getting the solution, understanding the solution is part of the problem and a big part of it. So either way, thank you for watching. If you like the video, if you enjoy it, please like it, subscribe. I'm trying to help people and sacrificing the time that I could be resolving this to explain and help the community. So stay tuned for more. Hope I can get the space, but with your like and subscription, certainly I will have the motivation to keep doing these videos. So see you soon.